Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone, and welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamental series, and we're continuing through our cloud compute topic. And in this episode, we are going to look at server virtualization. And here he is, back for more, Mr. Ronnie Wong. How are you?
I am doing well, Vaughn. Thank you again for joining us as we continue in our Cisco Cloud Fundamentals show, the show with all the C's that you had to actually kind of make sure that we got through. So,
yeah, you've been putting me through the ringer there, Ronnie. So
I have. I'm testing your alliterative abilities today.
Yeah.
So overall, though, when we continue down this path, especially in this cloud compute section, Vaughn, we're now going to server virtualization. Now, in the previous episodes, you might actually kind of logically in your head say, wait a minute, why did Ronnie start with the idea of the Cisco UCS, right? That unified computing system. Why did he choose that? And now he's going back to this basic topic of server virtualization. And the reason why I'm doing that is because fundamentally, right, what we're actually having a topic right here when you're actually studying for your CCNA. My assumption, though, Vaughn, is that everybody that's watching this, they already have probably a fairly decent grasp of what server virtualization is. So I thought it was actually more important that we spend a lot more time talking about the ideas of the Cisco UCS, but this is still a covered exam topic. So I kind of just pushed it off a little bit. Now, I'll actually take some of the exam objectives out of order to try and make them a little bit more logically sensed at this point. But for me, I said, let me make sure I get these episodes in here. And if I had to, right, I could squeeze the information that I needed, Vaughn, in this episode and not stretch it out to 2 or 3 episodes, but actually push it down and put it into a 30-minute segment. So I said, I'll end with that instead. And the reason also why, Vaughn, that we're doing it is that even though cloud essentially does revolve around the underlying platform technology of server virtualization, we're also about to talk about network virtualization as well. So I thought they'd go hand in hand together. So that's why I also did that too. Okay. So let's talk about this idea, Vaughn, when we start moving into the realm of servers and virtualization. So before we get started, this is how I always like to start, Vaughn. When I first actually start teaching students that have actually just really come into the IT field themselves, one of the terms that everybody gets confused at, okay, is this term, the idea of what a server is, okay? So Vaughn, whenever I actually started this, right, some people, whenever they've heard that term, what they think about right away is hardware, okay, all the time, right? They're thinking about the idea that it's not a regular workstation or desktop PC that they're talking about, but they're normally thinking of something that they saw inside of their business, and it's, you know, kind of either behind glass or locked away into a room, and they see these big, gigantic machines that are there, and what they're told all the time is, oh yeah, those are the servers that run our business, okay? So usually that's the term that we think about, right?
yeah, and the way I always used to try to describe it to people that are, you know, maybe not as computer savvy, I'm like, think of it as a special computer that serves other computers. So that way it's not just a piece of hardware. There's the software component that also, like, its job is to serve other computers. So it's just like yours, but specialer.
Yeah. Well, when it comes down to it, right, that's the other side of why people get confused, because sometimes you'll hear phrases like this. I'll just bring up a server, and if you're new to IT, like, oh my gosh, you're going to go, Vaughn, you're going to go out and buy a brand new server and get it installed just for that one thing that I was talking about? Well, no, what we're also talking about then, when you use that term server, is that there is a software that Vaughn was actually mentioning here, that what it does, it actually runs and does what we actually needed to. And that way it's actually software, like Vaughn was saying. So what is the difference then? And this is, again, something I want to make sure that gets into your head as well if it's been a long time since you reviewed it, okay? So what's the difference between a regular desktop machine and a server? Well, if we go to the hardware side of things, okay, Vaughn, in this sense, it really is about the performance of the hardware, okay? So on a regular desktop machine, these things are actually designed to work, okay? They're designed to give you good functionality and productivity, but the majority of the time, though, they're not really designed to do this. They're not designed to actually be highly functional when multiple people connect to them all at the same time, okay? And what that means, though, when I say that, right, simulate, right? Everybody actually connects one at a time, but very quickly. But what I mean by that is that usually it's designed for one person to sit behind and work with it, okay? When you go to a server, though, the CPU is a higher performance CPU. The actual RAM, there's usually a lot more RAM. The hard disk, if you're actually talking about conventional hard drives, they normally actually are functioning together in what we call a disk array of some sort that allows us to be able to access that and actually speed up the performance as well. The network adapters, there's probably more than one, and actually even the ability to aggregate those together to give you more bandwidth and everything else that you need to. So it's a higher level, a higher quality, a higher idea here of functioning. And also in server environments, depending on the criticality of the hardware server, it can even have dual power supplies. Okay? So that way you don't have a single point of failure inside of the actual hardware itself. All that's actually done the way that we can actually think about it. In a regular desktop machine, though, it doesn't do that. Okay. So when we talk about hardware, we can distinguish in that way. But Vaughn, there's also something else that we can distinguish it by, which is the idea of the users that are actually using it. So just like what you were mentioning, Vaughn, if I sit behind a regular desktop workstation, I'm the only one that's interfacing with my computer. So even right here on the show, I've got my laptop. Vaughn, you've got your laptop, but I'm not over here on mine actually connecting to yours and actually working with it. I'm really just working with what I have in front of me. So it's localized to me in my interaction that we have. Okay. So that's what we would talk about. Now, what about a server though, Vaughn? Okay. Now a server is different, right? When it comes down to the idea of what a server does, a server, Vaughn, how many users actually connect directly to that server and sit down in front of it and use it like they would a regular workstation? What do you think, Vaughn? How many do you think? Probably none, okay, is what it comes down to, okay? So nobody actually sits down at a server and just goes, oh, I'm going to use that as my regular desktop computer, okay? So Vaughn, what do you think?
Well, I think that'd be very few, if not really just nobody. I mean, maybe you every once in a while as a server administrator would come in and use it, but not on a regular basis. Like I'm going to sit down and work at this the whole day.
Right. So what does that mean then? So that means that a server has a different purpose than a regular workstation, okay? So we can come down to the idea of purpose as well, okay? So users that are sitting at a regular workstation, they're going to interact with it pretty much all day long, whereas on a server, your interaction is not you pulling up a chair and pulling out a monitor to attach to it, a keyboard to attach to it, a mouse to attach to it, so that you can just sit there at that server all day long and work with it, okay? The idea behind a server, though, is simple in this way, okay? The applications that we normally run on here is not something like PowerPoint or Word where we have to provide user input. But Vaughn, the types of things that we run on a server in terms of applications, we normally go ahead and we install the software that runs and does what it needs to, and then we configure it. And Vaughn, after that, human interaction of making that software do what it needs to do is pretty much nil, okay? So once we install that software that now acts as a server, okay, and we configure it, we normally don't have to touch it again unless something goes wrong, like what Vaughn was saying, okay? So the very fact is, that's what it's designed to do. So an example of that, though, Vaughn, is something like inside of our networks. If we run, let's say, DNS, okay, domain name system, where it converts the ability, right, of where I actually type in a name, it actually can look it up, and it can return back the IP address back to my computer so that we can make a connection. Vaughn, nobody is sitting at the other end saying, oh, Ronnie just sent this particular name. I need to look this up on the table. I need to copy and paste that back in and send it back to the computer. And then Ronnie has to open that up and make sure it actually gets into the host file on his computer to make it work, okay? All that's actually done by me simply typing and being on that network. That server responds and answers a query to what we actually need to do, okay? So the server itself is set up to do that. So I want to make sure that we get those two terms kind of understood here, that sometimes people do mean the idea of hardware, but the majority of times when we talk about server virtualization, it's getting it up and running and letting it do the things that it needs to do, okay? So inside of that, right, now we have to talk about the limitations behind the hardware side, okay? Vaughn, when it comes down to it, there is a limitation. After a while, even if you buy a fairly high capacity type of server, there's only so many pieces of software you can run before it may end up running out of RAM or out of hard disk size, or hard disk space, right? So when we have something like that, that means that there's a physical limitation to what that server can end up doing. So now, Vaughn, when we move into the world of cloud computing, okay, well, now I'm not the only one accessing this particular server anymore. What if there are hundreds of people accessing? What if there are thousands of people accessing it? Well, that server can get overwhelmed. It's the same thing that happens when you go to a website and it acts sluggishly sometimes because what? Everybody in the world is connecting to it at the same time. You might get the web page that comes back really quickly. You might connect to it and it tells you the server is busy. You might connect to it and it actually kind of fills in a little bit slowly. You name it, those are some of the limitations that we have in terms of the server. So how do we fix that? Okay, is what we want to talk about as well. Well, the other part of the title here goes into the realm of virtualization. Okay, so when we start talking about the idea of virtualization, the main component that we're normally talking about here is, of course, what we mean by virtualization. Okay, what we want to talk about is the idea of emulation here. Okay, so there's a difference between the term simulation, okay, and emulation. Simulation is essentially a fake device. Okay, it's not really doing any of the actual things that are going on. Okay, what it's actually doing is actually telling you what it wants you to see. So it's giving you expected answers when you actually interact with it, saying, here's what I'm going to do. I've taken your input, Ronnie, and I'm giving you a simulated response. But there's nothing in the background really running additional software. It's not doing that. It's just a simulator. But there's also an emulated environment instead. An emulation takes what is actually the hardware that's there and it creates a software version of that so that now when you interact with it, you're interacting with a software representation of the hardware. Okay, and that can include many different things, but the emulation actually is running. It's actually trying to say, hey, here's what's actually happening here, and it can send commands back to the hardware and do what we need it to do as well. Okay, so that's the basis of the server virtualization that we're generally talking about. It's not a simulated environment, but it's actually a really emulated environment that we're doing. The main unit when it comes down to server virtualization that you and I would interact with at that server level is what we call a VM or a virtual machine. Okay, a virtual machine is essentially an emulated computer or an emulated server at that point. Okay, it emulates things like the CPU. You generally hear it called a vCPU for a virtualized CPU. You may also emulate. It may also emulate the idea of a RAM, RAM, right? Random access memory, and you can also see that sometimes they call it VRAM as well, which is virtualized memory. Okay, storage. You access virtual hard disk drives. Okay, and you also access virtual disk controllers. So there's not real hardware that's actually saying, "Hey, I'm going to create." I'm actually connected to this hardware. It actually is emulating it in software, so it represents what we need it to as well. Same thing with our network adapters, as well as video cards that are actually there if you need it to. Other peripherals that usually we're not so concerned about the peripheral nature of virtual machines, but it can happen if you need it to. Okay, so all these are actually kind of neat. And the big difference here, though, Vaughn, is in the end of the day with a virtual machine, everything essentially is stored as files. Okay, that virtual machine is not stored as hardware; it's stored in individual files, is what you end up seeing. Okay, and that's actually kind of neat when you start thinking about it. So when you run that and it actually runs on your particular machine, well, then you're actually opening up a file, and the file now is acting like a totally different computer unto itself. So how do we get that to work when we start talking about the area of virtualization here? Okay, the way that this works, of course, is we actually use what we call a hypervisor. Okay, a hypervisor. The hypervisor is what creates the emulated hardware and manages the configuration. So let me show you an example of what I mean in block terms here. Okay, so on my screen, here's the basics of virtualization. And I'll zoom in here so that we can see. All right, so Vaughn, when we take a look at the left-hand side of the screen, okay, over here too, here's our traditional method that we use, right? We have our hardware. So I have my laptop in front of me, okay? We install an operating system on it. I don't care what operating system it is. It could be Windows, could be Linux, could be Mac OS, okay, if we want it to. And then on top of the operating system, we install our apps. Okay. But when we do that, that's the traditional way to do this. Now, Vaughn, it doesn't matter what these apps are. Okay. If you want to run them, you install them, they'll run, they'll do whatever else you need them to. Okay. But when we do this, we also end up with a limitation as well. I have 3 apps running here, Vaughn, but what if I have 16 gigs of RAM and I have, a terabyte of hard drive? And Vaughn, all 3 of those apps don't even equal up to, let's say, a gigabyte of hard drive space. Okay. Well, it's not that it's bad, but at the same time, Vaughn, it's a waste of what? The hard drive space or the solid state drive space, if you want to. Let's say that each of those applications don't really use any more than, let's say, 400 gigs of RAM. Not gigs, megs of RAM. Okay. Well, now I have 16 gigs of RAM, and I'm really only using about a tenth of that altogether. And I've got a hard drive that's a terabyte, and I'm only using about, let's say, 300 gigs. So let's be very generous and do 300 gigs of this. Well, now I'm wasting the actual hardware utilization of that traditional of that environment. Okay, so there's two types of virtualization software that we call hypervisors that can help us out. Now, it really depends on what you want. So in this one, you actually see that the hypervisors are actually on different layers. Okay, the first one that I want to talk about is kind of weird and backward here, Vaughn. It's called the idea of a Type 2 hypervisor. Okay, now everything here is actually emulated. Now, what that means, Vaughn, is that on the lower two layers, you actually notice something that right away here. Okay, it actually is the same as a regular traditional computer. Okay, you have hardware, you have your operating system which you run, but then you have this hypervisor that looks like it's on the same layer as the apps in the traditional environment, okay, in the traditional way of doing this. So that means this hypervisor runs like an application runs. But the difference here is that the hypervisor, though, it can take that operating system and the hardware and emulate it if it needs to. So it can actually take all the hardware and essentially say, here's a software representation of that hardware, okay? And that's what it gives us the ability to do. Then we instead can actually run different operating systems on the same exact computer. The hypervisor essentially announcing, here's how much hardware you have access to, and the hypervisor tells the operating system when you install it. Yeah, I don't see another computer right away. I see my own computer hardware, and that's all it does. Even though it's emulated, it does that. So Vaughn, you can install your apps up here. You can launch another operating system and install an app up here. And now this is something that we're not used to. We're not used to the virtualization environment. Is we've literally installed two different operating systems, and actually three altogether. Okay, if you think about the underlying operating system here, along with these other two, all on the same hardware components.
That's what I have on my computer
Yes,
for
you
where
do.
I can teach my Windows classes in Word
Mhm.
on Windows operating system and Word on Mac. I just fire up my virtual machine, I switch over my desktop, and there's my Windows, and I swipe over, and then there's my Mac.
Yep. So yeah, that is what we call a Type 2 hypervisor, and Vaughn is actually running something called VMware Fusion, which is the same one that I run when I do this. Okay, so that's one of those things that we can actually end up doing, and it's really a great, useful environment, especially for cases like what Vaughn and I do as well. If we're trying to represent this and do a demonstration of it, and it's really a lightweight test environment for us. Running it locally on my own hard drive is actually easier than me having to go and bring it up across the network and do all the other stuff that I need to do. But when it comes down to cloud computing, though, Vaughn, okay, in cloud computing, we talk about what we call a type 1 hypervisor. And this is where just about everything is virtualized in terms of the hardware. Now, Vaughn, we can see the difference between type 2 and type 1. The hypervisor is what gets installed first. Okay, so we don't install an operating system and then install the hypervisor. We install the hypervisor first. And most of these hypervisors are fairly lightweight in this installation. They don't take up a lot of space and they don't use a ton of RAM. They are really there to help us to manage this concept of creating virtual machines and configuring for virtual machines. And now we get rid of that underlying operating system here. And that gives us more abilities to do what? To actually get more VMs here because we're no longer having to worry about, do I have enough RAM? Okay, do I have enough hard drive space for the operating system that underlies it? Now, all that can actually be reduced, and now I can create more VMs in this one and have them directly managed by running what we call a bare metal hypervisor. Okay, and that's what it stands for when you install the hypervisor directly onto the hardware itself. Okay, so inside of data centers, inside of the cloud environment, this is the type of virtualization that we're normally seeing as far as the underlying infrastructure.
Is it safe to assume that that's more effective?
Well, it's more efficient. Let's put
Efficient.
it that way.
Okay.
Yeah, it's more efficient in the very fact that we're not having to run, like I said, my own operating system, and that reduces the amount of RAM that I can give to each one of those virtual machines. Now I can take full advantage of whatever's left over that the hypervisor didn't take up, and I can actually use that in my environment instead. So this is one of those things that we want to make sure that we do take a look at when we start doing this. Okay. So why in the world would we choose to do something like this, okay, and make that work? Well, there's a couple of different reasons. So let's take a look at my screen again. This will help us out too, okay? So now, let's say that I end up with 3 different physical hosts, okay? But I want to do what we call high availability, okay? So I want some of these things to actually be able to run whenever they want to. So let's take, for an example, app 1 and app 2, okay? I need to make sure that regardless if there's a failure on either VM host 2 or 3, that those applications will be up and going. So now what do? Well, you can actually create the same exact VM over on VM host 2, and the same one over here on VM host 3. And when you do so, that would mean if I lose VM host 2, VM host 3 is still up and going and still able to do what I need to. Okay. So it allows us to do that. So it's actually very good for things like high availability if we choose to as well. Now, when we do something like that, that can cause conflicts, especially if they're the exact same IP address and they're, doing what we need to. So normally inside of VMs, okay, especially with the type of hypervisor that we're talking about. See if I can scroll up on the screen here. Okay. The way that you configure this is what we call live migration. Okay. Live migration instead creates what we call VM states. Okay. So there's the idea of the VM state instead. So what we do is that the VM files, they don't reside on the individual VM host itself, okay, whichever one it is. They actually reside on a storage area network itself. And this allows for us to be able to transfer that if it senses that something is wrong with VM host 1, it can simply take one of these VMs and transfer it over to VM host 2. The files are not really moving, okay, because they all reside right here in the center. But what it does is it takes the VM state and it moves it over here. And then it says, all right, launch it up. And it actually carries it over, and there it is, okay? So it actually makes a copy of it, lets it bring it up over here, and then turns the other copy off that we want to. So that means you don't really lose a connection that much, okay? Because all it's doing is really, again, it's not moving the files. The files are in the same place. But the way that we reference that idea is actually going to be moved, is what we have here. When you talk about moving that idea of the VM state from one to the other machine is what ends up happening too, okay? So that is another reason that we would also choose to use this as well. So better resource utilization here that we've talked about, as well as being able to isolate the individual units too. The other one, of course, is load balancing. Okay, so Vaughn, the idea of load balancing here is a big one. So notice on my diagram here, okay, that you can see the utilization load right here where I have the red arrow. Okay, so Vaughn over on the left-hand side, 97% utilization. So this thing is running, 90%, 97% on RAM resources, whatever it is. One over here is 80% utilization. This one over here on the right, 20% utilization. But what we can do is we combine the idea of live migration together, okay? And we take all that information. We use the hypervisor management software. We can actually say, hey, I need to load balance, which means I can take this machine and essentially migrate it over here to do that, and then come up with a balance. And when I come up with a balance here, okay, we can do something like this, where now all of a sudden you'll notice that, hey, it kind of evened out a little bit more between these two machines. I didn't actually change this one because this one doesn't change. But with that idea of being a load balance, it actually allows us to do that more. Whereas on my laptop, if I run at 97% utilization, I just have to get rid of stuff to be able to actually do what I need to, okay? And then, of course, there's ultimately what we call fault tolerance, okay? Fault tolerance is actually interesting as well. It actually does work a little bit like the high utilization or the high availability here, in the very fact that what we do is that we might take one particular VM, so it's the one right here on the right-hand side of VM host 1, okay? So we take that one, and instead of running it, okay, what we do is we go ahead and we make a copy of it or over here, and we just leave it kind of off. But it does synchronize. So that way, any changes that are made over here, it will turn it on, make sure that those changes are also migrated over here. So in case the entirety of VM host 1 goes down, it simply turns this one on, okay? And when it turns it on, it just does exactly that. And now because they've been synchronizing the whole time, okay, so they're not really turned off, they're in kind of that sleep state of things. Well, now that they're actually turned on, well, now it allows me to actually be able to do that. So I now have complete fault tolerance as well across everything that we need to, okay? So there's a bunch of different ways that this can occur. But overall, though, this is kind of the solid basis. If you understand this, then realizing that the underlying technology behind all the other things that we talk about is actually going to be key in terms of cloud computing. Now, there are many different hypervisors, and you don't have to know all of these, but you do need to make sure that you understand a few of them. Okay, so the one that Cisco works most closely with is VMware. Okay, and VMware. Let me see if I can actually bring up their particular. Oh, they have okay. They've changed a lot of the different products that they have here, but VMware has one gigantic big product in terms of a hypervisor, which is ESXi. Okay, so that is the one that you have now. When you actually do that, it also has fairly strict hardware requirements. So you got to make sure that your servers will actually run this. But Cisco works very closely with them and have actually created virtualized appliances to run, which we'll talk about a little bit later on. The other competition, of course, is the idea of Hyper-V. Now, Hyper-V can be on Windows 10. It can also be on Windows Server 2016. It's actually been around since Windows Server 2008. Okay, R2 has actually been around since that particular point in time too. So you name it, here's their particular competition that was essentially a direct response from VMware. Okay, now at one point, Hyper-V was not as sophisticated as VMware was. Okay, but today, it pretty much is that sophisticated. If you want what we call, of course, almost a headless experience with virtualization, now what I mean by that is that there's no real direct interaction for you to be able to manage this thing. It essentially is designed to run on the server without you knowing that it's there, but then you connect in using the command line to do so. There's also the Linux kernel virtual machine, or KVM here. Okay, this is really probably the underlying technology behind AWS, okay, and their server virtualization is what we tend to see. And of course, inside of the private cloud and maybe even in the public cloud, Red Hat virtualization is another one, okay, as well. And then here's the one. So I'm familiar with VMware. I'm familiar with the Hyper-V solution. And the other one that I really kind of cut my teeth on was right here, which is the Citrix hypervisor. It used to be known as Citrix Zen Server, okay? So this is the one that I originally ran as far as a hypervisor and managing stuff with. So this one has actually been around for quite a long time too. Okay, so that's actually a big one, or it's not so big anymore. Pretty much it's going to be VMware or Hyper-V just about all the time. But in a practice environment, okay, if you want one that's absolutely free and will actually run 64-bit and 32-bit operating systems, it's going to be right here. Now, today, just about everybody does that. But Vaughn, when I first started running virtual machines on my own desktop and laptops, they only ran 32-bit operating systems. Well, Oracle ended up purchasing or buying out or inheriting VirtualBox. VirtualBox has actually been my choice for a long, long time, okay, in being able to actually run VMs in a test environment as well. People use it in server production environments too, so don't get me wrong, it's a fairly powerful platform. And this is owned by Oracle too. Now, my only issue with, of course, VMware, or not VMware, VirtualBox, is that, man, they tend to produce updates like crazy. So just as soon as you run it for about a month, you'll see it's like, here's an update. You run it for another month, here's another update. And then all of a sudden you realize that there's a lot more to managing this stuff because you have to change out of things as they go along. And that's what we call the VM agent that normally resides in every single virtual machine too. Okay. So all of those are actually just different examples of operating systems that we tend to see. Okay. When it comes down to operating systems itself, there are such a variety, but they all come in different Linux distros, as well as Microsoft's versions of Windows that you can run. So inside of the cloud environment, Vaughn, the majority of times, if you're doing server virtualization, I'm going to say just about all the time that you actually end up doing, the majority of it for anything that you do is going to be some type of Linux virtualization. And all the platforms have their own special edition of it as well. So, for example, AWS has their AMI, which is, of course, their Amazon machine instance that they have. And even inside of Azure, there's probably an Azure Linux VM that's also up there too. So just realize that they like doing that. But besides that, right, if you want to run anything like Microsoft, you have to make sure that you have the right licenses to do so, and you're just going to pay for it overall. Okay. So what does this help us do? Well, virtualization essentially is the foundational technology behind all of cloud computing. Okay, it really is. So just having a basic understanding of that, and hopefully this review kind of helped you out a little bit. And if it did so, make sure you stay tuned for, well, the rest of what we have in our show, because it really does go into some of the hardware behind the virtualization, as well as talk about the virtualized software and hardware that we have to, or the virtualized hardware, excuse me, not software, the virtualized hardware that we have to understand, at least from the Cisco perspective as well. So Vaughn, that's a great place for us to end this episode with this particular review, but we do have more Cisco-centric hardware to come, and so that's what we'll be hitting on in the next few episodes.
All right. Well, great review. Maybe some of y'all might have known some of these concepts. Maybe you've been working in a virtualized environment already, but it's always good to review, and we don't always want to assume that you know that. So thank you so much for joining us, but we're going to go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.